Here is section 2.6, and our big essential question is how can you solve an absolute value inequality? So in chapter 1 we looked at absolute value equations, and we've looked at inequalities, and now we're combining those two things here. So our learning targets for today, first we're going to solve some of those absolute value inequalities, and then we're going to use those absolute value inequalities to solve some real life problems. Okay? So first of all, an absolute value inequality that has the absolute value and not an equals anymore. Okay? So one thing to keep in mind is, like our last couple of sections with our compound inequalities, with our and or, if the absolute value is less than, that means the distance is less than 2, that means it's going to be an and statement. If I have the absolute value, it's greater than 2, that means my distance is greater than that, so it's going to be an or. And we'll walk through a couple of these examples. Okay? So here's our big core concept, and I want to explain this to you a little bit more when we're working through these problems, because this is actually honestly kind of confusing for me to read and see, so we'll walk through a few of them. The big thing that I see is when I'm writing my absolute values, I'm going to take what's written in here is one of my equations, right? And when we're dealing with absolute value, we're always going to have two answers. So to find my first answer, I've got my ax plus b is less than c. I just rewrite it. So as before with our absolute value, we had to change the sign of the constant on the other side. So I'm still going to do that. But when I change that sign, I'm also going to change the direction of the sign. Okay? So now let's look at a couple of examples. So we're asked to solve each inequality and then graph it if possible. So here I have the absolute value of x plus 7 is less than or equal to 2. So I'm going to write my first equation. So I have x plus 7 is less than or equal to 2. But then I'm going to write my second equation. X plus 7 stays the same. I switch the sign and I switch the sign. So I have to switch the sign on both of these. The other thing I notice is this is a less than. My absolute value is less than. So this is going to be an and statement. So now I can just solve, and in order to solve, I subtract 7 from both sides. So x is less than or equal to negative 5. And then I'm also going to subtract 7 here as well. So I have x is greater than or equal to negative 9. And remember that this was our and statement. And this actually does work because I can rewrite this as negative 9 is the smallest thing that x can be, and negative 5 is the biggest thing that x can be. So I can also graph that. And because this was an and, right, and these are not all evenly spaced, and yours should be on a graph, right? So again, here with my negative 9, it's going to be a closed circle, and also on my negative 5, a closed circle, and I shade in between. Since this is an and statement, we're going to shade in between. Okay? So now let's look at part B to solve this. Well, I see I have the absolute value is less than 0. Well, I know based on my definition of an absolute value that an absolute value can never be less than 0, so there is no solution here. Okay? So I can always just double check before I even start to solve it, because I know that it is not possible to have the absolute value be less than 0. So here are a few I want you to try. See if you can get both answers. Okay, so now here we're going to look at a couple of our or statements, and I know that these are going to be or statements because my absolute value is greater than my other constant. So let's first look at this A. We're not going to work all three of these together. We're going to look at A and C together. So my first step is I write my first equation, so C minus 1 is greater than or equal to 5. And then I write my second equation, so C minus 1. I switch the direction of the sign, and I switch the sign for my constant. That's how I get my two equations. So then I can add 1. So C is greater than or equal to 6. So when I add 1 over here, I'm going to have C is less than or equal to negative 4. So when I graph my or statements, right, we can graph them one at a time. So we're going to go with 0. We're going to say that this is 5 and negative 5. Okay. So now let's graph this first part. C is greater than or equal to 6. Well, I see I have to have a closed dot on 6, and it's greater than, so it's going to shade this direction. Okay. So now let's look at our second part. C is less than or equal to negative 4. Well, with that equal to, I have to have a closed dot at negative 4, and I'm shading this way. Okay. So I see that my shading does not overlap, but I still have two parts of my graph. So now I want to look at part C with you here, because there are several steps that we need to take before we can start solving our two equations. So the first thing I notice is my absolute value is not all by itself. So that has to happen first. So the first thing I actually need to do is subtract 1 from both sides. So now I have 4 times the absolute value of 2x minus 5 is greater than 21. Oh, sorry, 20, because I have to subtract that 1. So now my absolute value is still not by itself. So I divide everything by this 4. So now I have absolute value of 2x minus 5 is greater than 5. Once I'm at this point and the absolute value is the only thing on one side of the equation, now I can set up my two problems. So I have 2x minus 5 is greater than 5, and then I have 2x minus 5, switch the sign and switch the sign. So that's kind of just a way you can always remember it. So now I solve by adding 5 to both sides. So 2x is greater than 10, and dividing by 2, so x is greater than 5. And I'm doing all this to undo what's being done to x so I can get x by itself. So again over here I'm going to add 5 and add my 5. So 2x is less than 0. And now I divide by 2. So x is less than 0 because 0 divided by 2 is 0. So again, this is an OR statement, so I can always draw this out on my number line as well. Okay, we'll start with 0 there and 5 there. Let me get some colors. So for this one, I see x is greater than 5. So I have to have an open dot on 5 because I do not have the equal sign, and since it's greater than, I can shade to this side. Okay, so now let's look at our next one. I've got x is less than 0. Again, I have to have an open dot because I do not have that equal to, and it's less than. So my shading will be to the left. So now I've solved it and graphed it. The big thing here is, don't forget, before we can start solving our two equations, we have to get that absolute value all by itself. And then you can set up your two problems to work with. So here are some to try. I really want you to try this number 6, right? Because there's many steps we need to do. So make sure you can do that one first. So now here's this real life situation, right? Our second learning target. So you're buying a new computer. The table shows the prices of computers in a store advertisement. You're willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your criterion? So first, what this really means is when we find the mean, I add all of my prices up and divide by the total number. That's how I find the mean, the average. So that's going to be the first step. But I know I can deal with an absolute deviation of at most $100. That tells me that I'm willing to go above the mean by $100 and below the mean by $100. And then I can find how many computers fit in that section. Okay? So the first thing I need to do is I need to find the mean. So in order to find the mean, I take all of the computer prices and I add them together, which gives me $66.40. And then I divide by 10 because there are 10 different computers. So my mean price is $664. So now I can write my inequality. Okay, so X is going to be the price I'm willing to pay. And I said that I was willing to go within, so less than or equal to $100. Okay, so now I can set up my two problems and solve. Okay, so here we set this up as a compound inequality. Okay. We can also just set it up how we were doing it before. But I also know that this is going to be an AND statement because this is less than or equal to. So I know I've got $100 on either side, right? Because I'll pay $100 less and I will pay $100 more. So then to solve for this, I'm just going to add my 664 and see where I end up. So then I can simplify. So this tells me I am willing to spend between $564 and $764 on my computer. So then I can go back up to these computers and see which ones fall in that category. So this one does, and this one does, and this one does, and this one does, and that one, and that one. So those computers that are circled are the ones that I'd be willing to pay. So I can use many different steps here in different ways to solve this, but I still want to start with the mean, and then I know that I can go up 100 and I can go down 100. That's what that absolute deviation means. So now what if I'm going to do that deviation of $75? Now which computers am I able to buy? Okay. So now let's go ahead and look through our learning targets and see how we did. First, we solved some absolute value inequalities, and we solved them even when they weren't as simple, right? If they have multiple things, like for example, if I have 3 times the absolute value of 2x minus 1 plus 4 is greater than or equal to 12, there are some steps I have to do here first. So make sure you can understand those steps. And then I use some absolute value inequalities to solve some real life problems, some of those word problems. So now that we've completed these learning targets and looked through them all, go ahead and work on your homework for this section.